We set out to build an 11-act cinematic Western, complete with character arcs, dialogue, and consistent action, using nothing but generative AI models. That required preserving the exact look of our protagonist, matching the chiaroscuro lighting, and keeping the dust-choked atmosphere identical from Act 1 all the way to the epilogue. Trying to achieve that consistency by manually typing prompts into a web interface quickly spirals into a disjointed mess of hallucinated faces and erratic camera angles. Add in the reality of cloud computing, and the pipeline shatters. You get hit with API authorization errors, cold start timeouts on heavy video models, and remote GPU quotas dying right in the middle of a render. Better prompting cannot fix a server outage. Automating long-form storytelling requires a software architecture that manages the machines rather than just talking to them. The solution relies on a lightweight Python script and a local database, running entirely on a standard laptop. This local brain maintains a central database of character mastercards and style guides. For every new shot, it injects these fixed visual references into the instructions, ensuring that the JC Black appearing in Act 1 is mathematically identical to the one in Act 10. But even with perfect visual prompts, generative video models have no inherent sense of pacing. They don't know how long an action or a spoken line of dialogue should take. We bypass this by having the system synthesize the voiceover audio track first, before it ever touches a video model. Once the audio file is generated locally, the script measures its precise duration down to the millisecond. It takes that time value and calculates the precise number of video frames needed to match the dialogue, wrapping that math into the final visual prompt. Before a single pixel is rendered in the cloud, this local orchestration guarantees the final video shot will pace perfectly with the spoken performance. The local controller then fires that mathematically optimized prompt across the internet to a remote server. We use Hugging Face cloud spaces to provide the heavy lifting, offloading the compute-intensive video rendering to dynamic GPU clusters. To keep the servers from crashing under the weight of these massive models, the system uses lazy loading, pulling the weights into video memory only when an active request comes through. But cloud resources aren't infinite. If you run out of compute quota halfway through rendering a scene, the job simply dies. Instead of a hard crash, our script intercepts the error and triggers an automated cascade, pivoting the prompt to a backup video model. If every video API is exhausted, the system drops to a third tier, rendering a cinematic keyframe image at zero cost. This multi-layered safety net guarantees the production pipeline keeps moving forward, securing a usable visual asset for the timeline no matter what happens on the server side. The remote server ships the finished video and audio files back to the local hard drive, where they are automatically indexed and packaged for the editor. The resulting scenes feature dialogue that lands seamlessly on the action and visuals that hold their aesthetic, all generated with zero human intervention during the render process. Trying to cram massive AI models onto consumer hardware restricts what you can build, while relying purely on cloud interfaces leaves you vulnerable to rate limits and lost work. This engine manages those risks by decoupling the creative logic from the brute force rendering. The local machine holds the state, and the cloud provides the temporary muscle. Generative film production is becoming a game of resource management. Moving the orchestration to a local state engine ensures that even when the cloud fails, the narrative remains intact.